I'm going to run through the solutions to this quiz. We're taking the derivative of the natural log of 3x squared plus 1. The derivative will be equal to the reciprocal, 1 over 3x squared plus 1. Remember, you have to multiply by the derivative of the inside function. So the derivative of the inside function is 6x. If we multiply by 6x, that's going to give us a 6x in the numerator. Be careful there, you can't divide 3 out of the top and bottom because 3 doesn't divide into 1, so we are just done with that one. All right, the next one, it's 4 log base 2 of 5x. Of course, we can factor out the 4 and we can multiply that in at the end of the problem. Just a reminder here that the derivative of something like the log base 2 of x, remember that like the natural log function, you are still going to have a reciprocal. It's going to be 1 over the inside function, but you're going to multiply by the natural log of the base. So it's 1 over x ln of 2. So the same kind of thing here. It's going to be 1 over 5x times the ln of 2, but you have to multiply by the derivative of the inside function. Derivative of the inside function is 5. And that's going to give you a 5 in the numerator here, which will end up canceling. And you're going to end up with 4 over x ln of 2. Right? On to the next one. I would use natural log rules. I would pull that 5 out in front, and that'll make your life a little bit easier. So we're going to end up with, of course, a 5 being multiplied in front that will be multiplied in at the end. We're taking a reciprocal, so it's going to be 1 over x squared minus 3. And then you're going to multiply by the derivative of the inside function. Derivative of the inside function is 2x. So we're going to have a 2x there. And again, a little bit of simplifying can happen. You'll get a 10x over x squared minus 3. And that is your final derivative there. Okay. Next one, derivative of 3 to the 2x power. The derivative is going to be itself times the natural log of the base, so times the ln of 3. And then remember, you have to multiply by the derivative of the inside function. And it doesn't look very simplified, but nothing there simplifies unless you just want to write something in a different form. Next one here, be careful. That is not ln of x to the 5th, like the 5th being the inside function for the natural log. You cannot bring that 5 around out in front. This is a power rule problem first, so you're going to have, well, actually 5 comes around in front, but it comes around in front because of the power rule. So it's going to be 5, inside function doesn't change, drop your power by 1, and then you multiply by the derivative of the inside function. Some people might write all of that over x, or 5 over x times the ln of x raised to the 4th power. A couple different ways you could write that. Okay. This one's going to be logarithmic differentiation. You might want to rewrite it as y equals 2x to the 4x power. Remember, with logarithmic differentiation, you're going to take the natural log of both sides. So we take the ln of y is equal to the ln of 2x to the 4x. What that's going to allow us to do is to pull that 4x around in front. Okay? So on the left-hand side, the derivative of the natural log is 1 over y times the derivative of the inside function, which you could write dy dx, or you can write y prime. The other side, it's a product rule. So it's derivative of the first times the second, plus the first times the derivative of the second. Derivative of ln of 2x is going to be 1 over 2x times 2, which ends up just being 1 over x. So the interesting thing there is that the x's actually cancel. Okay, and what you're going to end up with then, you want to solve for y prime, so you're going to multiply both sides of the equation by y. You'll multiply this side by y, and this whole side of the equation is getting multiplied by y. Okay, now don't leave that as a y. We know that y is the same thing as 2x to the 4x, so you're going to see the original function pop up back in here again. So we're going to get y prime is equal to 4 ln of 2x plus 4, all of that times the value of y, which was 2x to the 4x. So these are big and ugly. They usually don't simplify very much. That's all that's going on there. Speaking of simplifying, e to the natural log of x is just x. So e to the natural log of x squared minus 5x plus 1 is just x squared minus 5x plus 1. Be careful. That whole thing is being multiplied by 4. So you will need to distribute that in. And that's actually just y. So it's going to be 4x squared minus 20x plus 4. Don't forget to take the derivative. That's the calculus part. So y prime is equal to 8x minus 20. Okay? Integral problems. Cannot stress enough. Chain rule, chain rule, chain rule. Okay, this is 4x minus 7 to the negative 1 power. If you tried to apply the power rule there, it would fail because you get a 0 exponent, okay? So this is going to be a natural log. It's a reciprocal function. Derivative of the inside function is 4. You don't have a 4, so multiply in a 4. You're going to have to balance that with a 1/4. Reverse the chain rule. Derivative of the inside function goes away. Remember, the integral of a reciprocal function is the natural log of the absolute value of whatever you took the reciprocal of. We get that 1/4 out in front. Don't forget your plus c. Okay, remember, you can also take the derivative and see if you get back your original equation. I would factor the 4 out here. And so, of course, that's the derivative of the natural log function. So it's just natural log of the absolute value of x. Don't forget that absolute value. You're going to have a 4, and then you're going to have a plus c. Okay? This one here, you can factor out the 6. You need a 4 as the derivative of your inside function. You're going to have to balance that with a 1/4. And again, I would pull the 6 out as well. E to the 4th is its own derivative, so it's its own, sorry, e to the 4x is its own antiderivative. Out in front, you've got 6 times a 4th, which is 6/4. That ends up being 3/2. Of course, when I reverse the chain rule, the derivative of the inside function 4 went away. And we end up getting 3/2 e to the 4x plus c. Okay, next one here. Notice the derivative of the denominator would be 5x to the 4th, which is similar to the derivative of the numerator. We can treat this like a reciprocal function. So again, I would take a little bit of extra care here. The 3 is not really compatible. I would probably factor that out. Right, this is a reciprocal times x dx. The derivative of the 5, times x to the 4th. So we got the 3 out here, we got the x to the 4th here. The derivative of the inside function would be 5x to the 4th. I can multiply by 5, balance it with a 1/5, okay? Reverse the chain rule, derivative of the inside function goes away. The antiderivative of a reciprocal is a natural log of the absolute value, in this case of x squared plus 2. 3 times 1/5 out in front is 3/5, and then we have a plus c. Okay, be careful. Looks like a reciprocal function. It's not. That's a negative power. This is 2 times 3x minus 1 to the negative 4th power, okay? We're not going to get a 0 exponent. This isn't a natural log. Don't get thrown off by that. This is just a chain rule and power rule problem. So I would probably pull out the 2. You're going to raise the power by 1. And remember, the derivative of the inside function is 3. You need a 3. You're going to have to balance that with a 1/3. Okay, so we're going to have a 2 out in front. We're going to have a 1/3 out in front. Now you're going to raise the power by 1 to negative 3. Divide by that new power. Okay, and I think we have everything there now. I believe that's going to be negative 2/9 times 3x minus 1 raised to negative 3 plus c. Again, you could drop this to the bottom as a third power function. You could have negative 2 over the quantity 9 times quantity 3x minus 1 to the third power. Would be another way you could write that. All right, number 13. Yes, this is cotangent. However, we don't know how to integrate cotangent. But it's also a reciprocal function. Cosine is the derivative of the inside function. That's 1 over sine of x times cosine of x. Cosine is the derivative of the denominator, so we can use that as our derivative of our inside function. Reverse the chain rule, derivative of the inside function goes away. The antiderivative of a reciprocal is just the natural log of the absolute value of whatever you took the reciprocal of. And you can add c. And so that is all that's going on with that one. Pretty straightforward. Okay, fundamental theorem. Notice we are taking the derivative of an integral. Essentially, those things are going to cancel out. You should not have to do the antiderivative here and substitute in and then take the derivative, although I suppose you could in this one. The point is, it's just going to end up, essentially the derivative is going to cancel this integral. It's going to end up being that function, but in terms of the variable they have here. So in this case, that's going to be x squared plus 3x, okay? Again, that's a derivative, so you're not going to have a plus c or anything like that. Now, this one's a little trickier. Yes, you're taking the derivative of the integral. Yes, they're going to cancel out. You're basically going to be left with this. But be careful. The variable is going to be a 6x there in place of the t's. So that's sine of 6x, cosine of 6x. And also, you do have to apply the chain rule. The derivative of the inside function is 6, and so you have to multiply by 6.